Hi all, I'm Kyle. Welcome to our series of tutorial videos on BioRT HBV model. In this video, I'll be talking about the input files required for running BioRT HBV model, and in particular about database file or CDBS files. Here, I have listed all the BioRT HBV input files that we need, and they are CDBS file, chem file, CINI file, soil file, receipt chem file, results file, and parameter file. So the first five files are created for running BioRT HBV model itself, whereas the results file and parameter file are obtained from HBV light model. We have another video that details about how to obtain these files from HBV light model. So in this video, the focus is going to be on the CDBS or database file. This database file has the same format as the database file of the widely used crunchtop model. Since this is a short video where I can't cover everything about the database, if you want to explore more about database, please do refer to the manual of crunchtop to learn more. So CDBS file has several blocks, but I will be talking about those which are most relevant to the BioRT HBV in this model. And these blocks are primary species block, secondary species block, mineral species block, mineral kinetics block, and ion exchange block. So let's look at each one of these step by step. So first, primary species. In the database, first we list all the primary species, and the format that we follow is shown here. And you can also see some examples. So here we can see that first we have the species name, followed by the Debye-Hückel size parameter, and then its charge, and finally the molecular weight. Under the primary species block, we list all the primary species, and then we go into the secondary species block. In case of secondary species block, we have a much lengthier format. So in this case, we start with the species name 2, for example, here carbonate, and then we specify the number of species in the reaction. For example, the carbonate reaction has two another species, that is H+ and bicarbonate. So we specify 2 as the number of species in reaction, followed by the stoichiometric coefficient of each of these other species and their name. So once we have completely written about the stoichiometry of the reaction, we start the log KEQ array, where KEQ refers to the equilibrium constant of the reaction. We can see that there are 8 KEQ values here, but the model will only read in the second KEQ value, and this is the one you have to edit if you want to change the equilibrium constant for the species when you are running the model. After the log KEQ array comes the Debye-Hückel size parameter, followed by charge, and then molecular weight. After listing all secondary species, then comes the mineral species block, in which mineral species are listed based on the almost the same format as secondary species. There is only one difference, and that is that we have an additional term called molar volume just after the species name. The molar volume of the mineral should be specified in the units of centimeter cube per mole. After the mineral species block comes the mineral kinetics block. So here I am showing the format used to specify the mineral kinetics for TST reactions, or the reactions that depend on transition state theory rate laws. For this, the first line specifies the mineral species name. The second line gives the label. I will I will talk about the label more in the next slide. In the third line, there is the type of reaction. The reaction type can be either TSG or monod. Since we are showing TSG reaction here, it is TSG in this case. The fourth line is rate, which should be in log scale. So K is the reaction rate constant, and we should use the log scale. Then we have the activation energy in kilocalorie per mole. And finally, the dependence, in which we specify the name of the species on which the reaction rate depends, followed by the exponent of dependence. So currently, we can only have one species on which the reaction can depend. So keep that in mind. Now let's see an example for the mineral kinetics. TSG reaction. So here we are showing some calcite dissolution reaction, and we can see that in the first label, in the first block, in the first reaction, we have the label default, type is TSG, and we have the rate here, activation, and there are no dependents. So in this first reaction, the calcite dissolution does not depend on any species. Coming to the second one, we can see that the label is H+, which is actually which we have actually used to indicate that this reaction depends upon the H+ species, and the dependence exponent is 1. So now you can see why we have this label. So this label is used to differentiate reactions of the same mineral, but with different rates or dependence on species. Next is the mineral kinetics for monod reaction. If you look here, the format is almost the same as TSG reaction till activation, and then comes the monod terms and inhibition terms. For monod reactions, we can specify as many electron donors, acceptors, or inhibitors, unlike for TSG reaction, where we can only specify one dependent species. So in monod terms, we specify first the electron donor or acceptor name, followed by the half saturation constant. You can have as many electron donor or acceptors as you want. After specifying the monod terms, then comes the inhibition terms, and you can write the inhibitor species name followed by the inhibition constant. So this is an example of soil organic carbon decomposition reaction. And in the first reaction, we have a simple reaction where there is no dependence on any monod term or inhibition term. Whereas in the second set of reaction, which is labeled as test, we have a monod term, which is SOC or soil organic carbon, and the exponent and the half saturation coefficient is 6 into 10 power minus 4. So in this case, we have not specified any inhibition terms, but you are always welcome to use inhibition terms when you are setting up reaction networks for your sites or catchment. Finally, we come to the ion exchange block. In case of ion exchange block, the format is such that first we have the species name, and then the number of species involved in reaction, followed by the stoichiometric coefficient and the species names, just as we saw for the secondary species and mineral species. But after that, we have only one log KEQ value that we use instead of 8 values that we saw in previous reaction for the mineral species and secondary species. So here we have one log KEQ value, followed by charge finally, that is charge of the species, ion exchange species. So now that we have looked at all the blocks, so I'm going to open the CDBS file itself and just scroll through it and show you the different blocks. So here is the CDBS file, and you can see that there are some information on Debye-Huckel parameters here, but then we have the primary species charting from here, and you can see the format is same, that is Debye-Huckel size parameter, charge, and then molecular weight. So if you scroll down, you can see end of primary, which shows that primary species block is over here, and the secondary species block starts here. And secondary species block is a long list, so I will just go to the next one, like end. So here you can find the end of secondary species, after which we have the gas species, but here for our case, we are not using any gas, so we'll skip that. And come to mineral. So these are the mineral reactions that we specify here. After mineral species, comes the reaction kinetics here, that is shown by begin mineral kinetics. And you can see the reactions label, type, rate, activation, etc. So let's go to the end of, if you scroll down, you can go to the end. Okay, this is the end of mineral kinetics, and we have the ion exchange reactions here. So first we have a ion exchange X X minus species, which we use to show like the sites of ion exchange. And now there are the species with their log KEQ value and charge. So that is about the CDBS file. So in this video, we looked at how the database file is organized and where the different species and their and the reaction parameters are present in the database file. Thank you.